In this video, we want to take a look at organizing and summarizing data. We really want to look at quantitative data. Read that quantity, A-N-T there in the middle, not quality, which would be qualitative. So we want to look at quantitative data. And here's what we're going to do. We're going to take a couple of quick steps. We're going to organize this raw data into classes, just groups, if you will, classes. And then we're going to create a table for the data. And we're going to look at four different things there: frequency, relative frequency, cumulative frequency, and relative cumulative frequency. And for this class, I'm going to use the example, Chapter 2, Section 2, question number 28, and its companion question in Chapter 2, Section 3, question number 14. And those two are on pages 90 and 99 in your book. So what we're going to do, here's our little flow chart for it. We're going to organize the data. We're going to put it into classes, starting with the lowest value. Then we're going to create these four tables, and then we're going to draw some graphic displays that go with those tables. So step one, we want to put into classes and tally the frequencies. Now, the book suggested that we use a lower class limit of $35,000 with a $5,000 class limit. So starting at 35, that gives us a lower class limit meaning the small number in that range. And that will be 35, 40, 45, 50, 55, 60, 65, and $70,000. These are disposable income numbers for the United States. So here we have the chart straight from the book, and they're in whole dollar figures. So what we'll use as our upper class limit is $1 less than the next lower class limit. So the first class will be starting at $35,000 and go up to $1 less than $40,000. In other words, $39,999. Then the second class will start at $40,000 and go up to $44,999. So we've got our raw data here. Let's put them into classes. Now here I've made up a little chart, and there are the upper class limits, UCLs, and lower class limits, LCLs. Now, in the frequencies, what I did was I just took that raw data and I had a little sheet of paper, and each one I just read it off and I made a little tick mark. So at 39,662, and I made a tick mark there. Next one, 42,499. 42 goes right in there. Made a little tick mark there. 48,808. 48 would be in this one. Made a little tick mark there. And I went through that whole table across, all the way down to 65,262. 65,262. Made a little click there. And there were all my little marks on the paper. I then added them up. So there's 2 of those, 10 of those, 5 of those, 15 of those, and so forth. I want to add that column up, and it better come to 51 because there was 50 states plus the District of Columbia, so 51 total. Next piece I wanted, and that's it. So it said create a frequency table. Back here, create a frequency distribution table. There it is. Lower class limit, upper class limit. There's the frequency. At the bottom, I totaled it. Next thing we want to take a look at is the relative frequency. And that's simply how many of these are there compared to the total. There's 2 out of 51. 2 out of 51 or 0.0392. How many are there between $40,000 and $44,999? Answer, there's 10. What is that relatively speaking? Answer, 10 out of 51. 10 out of 51, like 0.1961. Well, I did that all the way down, 5 out of 51, 15 out of 51, and so forth. Got down, put down the number. I wanted to double check my work. I add them all up. Not surprisingly, in fact, mandatorily, it comes up to be 1. In other words, what percentage of the whole is everything? Answer, 51 states out of 51, or 1.0. So that's your double check. This 51 here is used to divide this number divided by the total, gives you this number. Sum all those up, you got the 51, sum up all those, and you get 1.0. So that takes care of what? The relative frequency distribution. Next up, cumulative frequency distribution. Cumulative frequency is how many have occurred in that period or that class plus how much has occurred before. Well, in our lowest class, we had 2 and nothing had occurred before, so we add them up. 1 plus 2 is 2. Next one, we had 10 more, so we take the 10 that we had here, add it to the 2 that we had here, and we get 12. In our next class, we had 5 additional, so we add that 5 to the 12, and we get 17. And we just keep on doing that. Add 15 to get 32, add 6 to get 38, add 9 to get 47, add 3 to get 50, and add 1 more to get 51. And this 51 right there should be the same number as this right here. And you can see those two are. And that's cumulative frequency. The last part of the table we want to do is cumulative relative frequency. Well, we're going to use the same technique. We're going to take this number and add everything up before it. So 0 plus 0392 is the 0392. Add 0.1961 to that number, get 2353. Add 0.0980 to that, and you get 0.3333, 1/3 of the way through. Double check that, by the way. Yeah, 1751st are indeed 1/3. And we just keep on going until we get down to the bottom. And the last number in the cumulative relative is the same as the 1 of the whole. So there it is. The 1 matches up to the 1 right there, just like the 51 is the same as the 51 there. Those of you that have used Excel probably picked up that once this frequency is done, these other ones are just done by formula. So you just write the formula in, drag it down, and boom, it's finished really quickly. Let the computer do all the arithmetic for you. Now, we've got 4 things. We can display them a bunch of different ways. First way is a histogram, and that's a graph that uses rectangles for each class of the data, where the height of each rectangle is the frequency or the relative frequency of that class. In other words, it looks like a column chart that you've made for decades. Well, at least since about 5th grade. Now, there's a couple of differences. One is the width of each triangle is the same, identical widths, and each rectangle touches its adjacent one. So there's what our numbers look like. So you can see right here we had 2, then it went up to 10, then we had 5, then we had 15, then we had 6, then we had 10, then we had 4, and then we had 2 that were over 70,000. And that corresponds to that. So number 1, I'm sorry, it was over 70,000. That corresponds to the same numbers. In Excel, this horizontal axis is called the bin, but you'll notice here I said that it was a bin, but it's disposable income in dollars. And this is how often it occurred. It's a frequency. So this graph is what yours should look like in these kind of problems. It's got a good title. It's got a legend. It's the legend on the vertical is labeled for frequency histogram. It will be frequency. And across the bottom is the thing that we're measuring, in this case, disposable income in dollars. Now, if we wanted to do a chart of the relative frequency, well, it turns out this is the same thing. Instead of having this axis say frequency, we could draw another axis over here that said relative frequency, label this as 1.0, 3/4, 1/2, 0.25, and 0, and that chart would be absolutely the same. Now, there's some more ways we can display the cumulative ones. We can do a cumulative frequency distribution to display the aggregate frequency, in other words, the total number of observations that's less than or equal to that. And that line will start low and gradually get bigger. And likewise with the cumulative relative frequency distribution, it'll end at 1, start at 0, end at 1. Now, back earlier on, yeah, that slide right there, I said frequency. Well, there's some other terms for it, frequency, polygon, ogive, and so forth. You can look those up in the book. But what you discover is they just give a different name. Like this, you might call a bar chart. Well, really, bars go horizontally, so this is a column chart. But since it's doing frequency, the bars are of equal width and they touch each other, we call it a histogram. So you've learned something new, mainly just the new use of the word, but it looks a lot like other stuff you've done. And ditto with other things like the ogive. The things you've done already just have a new name because we're working with a distribution. So it works as a table or as a graph if we want to do cumulatives. For continuous data, we just display the total number of observations that's less than or equal to the upper class limit. Some we graph by plotting off the midpoint. The class midpoint is determined by adding 2 consecutive lower class limits and dividing the result by 2. So we can have frequency polygons where we put class on the vertical axis and frequency on the, class on the horizontal, frequency on the vertical, and then we just put a dot at the midpoint and then draw a straight line between the consecutive points. We can do the ogives, which are just like the frequency polygon, except we use cumulative frequencies or cumulative relative frequencies and put the upper class limits on the horizontal and the cumulative frequencies on the vertical axis and draw it in there. So you've drawn graphs like this for many years. These just have new names, and I'm telling you what to put on the vertical and horizontal axis. So in summary, what we wanted to do was we organized the raw data into classes. We then created a table, actually a table that had 4 different pieces in it. That's section 2.2 and 2.3 in your textbook. And then we graphed them. So to review their quality classification based on some attribute or characteristic, color, for example, and then quantitative, like we were doing here with the disposable incomes, providing a numerical measure of the individual. And it can be either discrete, finite number, countable number of possible values, or it can be continuous, an infinite number of possible values.